In this video, we will be graphing logarithms. So we kind of talked a little bit about logs in the previous video. So here, remember that if we have an exponential equation, y is equal to 2 to the x, we basically have a horizontal asymptote. We have a y-intercept at 0, 1, and then in this case, it's going to be this exponential growth going upward, okay? So, so we had a y-intercept at 0, 1. We had a horizontal asymptote at y equals 0. Okay, so that's what we can have, and we have this growth. So what does the logarithm look like? So a log, which is basically the inverse of this guy, what would that look like? Well, remember that when we were looking at inverses, one of the things that you know is that this is kind of a mirror image across y equals x. So if I were to choose this point, which is going to be 0, 1, and I were to graph it because it's our inverses, this is now going to be 1, 0. So now you have an x-intercept. Here you have y equals 0 as your asymptote, so now you're going to have x equals 0 as your asymptote. And if I pick every single individual point of this graph, you're going to get something that looks like this. So this is actually the logarithmic equation. So here you don't have an x-intercept, y-intercept, you have an x-intercept at 1, 0, and you have a vertical asymptote at x equals 0. So everything has been swapped. So this is basically what the logarithm graph looks like. The domain and the range also has swapped. So the domain before for the exponential was negative infinity to positive infinity. So the domain for this guy was negative infinity to positive infinity. Now that has switched to the range over here. The range for this guy was 0 to infinity. In this case, it's going to switch to the domain of the log function. So these guys have just swapped, okay? And the logarithm obviously is on the parent function worksheet, so you can see it. Okay, so this is basically what it looks like, okay? So now what you're going to be able to do is now we can go ahead and graph something that looks like this. So if you had a log x minus h plus k, you can graph something that looks like that, okay? So now that we kind of know what the general gist of this guy is, all right? So let's do a couple of examples. Graph and find. Let's just find the domain because the range is going to be all real numbers, okay? Let's just find the domain. Okay, so let's start off with y is equal to log base 3 of x minus 2. So what would that look like? So we first start off by graphing the general log function. Remember, it has a vertical asymptote. It has an x-intercept. It kind of looks like this. Kind of like a square root function, okay? Now, all we have to do, this 3 doesn't really do anything. It just tells you how flat or open this is. Later on, you can plot a couple points. But all this is doing is shifting it 2 units to the right, okay? So we're going to go 2 units to the right-hand side. So I'm going to go from 1, I'm going to go 2 units over. So now I'm at 3. Okay, but notice when I move this over, what else is going to move over? The horizontal, the vertical asymptote. So when you had a shift like this before in the x value for the exponential, it didn't move, but here it's going to move. Okay, so this guy was at 0, now it's going to move over 2 units, so now the vertical asymptote is at 2. So now this graph is going to look something like this. Okay, so here our domain is just going to be starting at 2. 2 is not included, and it's going to go off to infinity. That's going to be my solution. Okay, let's try this one. Let's say we had negative log base 3 of x plus 1 minus 3. Okay, so we're going to start off with the general log. So the general log kind of looks like this. At 1. Okay. Now this middle part, we're going to start with the inside 1. So we're going to shift it 1 to the left. So this guy's going to go over to the left. So is the asymptote. So now this asymptote is not going to be at 0. It's going to be at minus 1. Okay. This 1 is going to move over. So now it's going to be at 0. Okay. And now we're just going to graph it. Okay, so it looks something like this. Then what you're going to do is you're going to deal with this negative sign. So everything is going to be flipped. So notice the asymptote really doesn't flip. It still stays in the negative 1. So that guy still stays there. But now this guy, see how it's increasing from the asymptote up. Now it's going to be decreasing from the asymptote to 0. Going to be decreasing from the asymptote now to 0. Okay, this guy was from 0, it was increasing to the first quadrant. It's going to flip, so now it's going to go decreasing to the fourth quadrant. So kind of like that. So it's kind of swapped. And then finally what we're going to do is we're going to take this minus 3, which is going to move everything downward. Notice that the asymptote is already there. It's not going to move any more down. So moving down 3 units, the asymptote stays the same at negative 1. Okay, so here we were at 0. Now we're going to go further down 3 units. 1, 2, 3. So now it's going to be right here. So now if I graph it, is going to look something like that. Okay. Now you can find what this point is. When we solve equations, it might be a little easier to find these x-intercepts. It was easy for us to find it with the y's, with the exponentials, but with the logarithms, it's going to be a little difficult. We need to do a little bit of the of solving logarithmic equations. So here the domain, you can clearly see it is going to be from negative 1 to 0. Okay. Now there's going to be some problems where the domain might be a little hard to find. So let's say if I give you this example and I tell you y is equal to 3 log of 3x minus 4 plus 7, would there be an easier way for you to figure out where the domain is? Okay, without having to graph it? And the answer is yes, you can find what the domain is without having to graph it. If you just think about what the log looks like in general, so the parent function looks like this. If I were to just draw it as an inequality, it's all x values that are greater than 0. That's basically the domain. Okay, so whenever I say 0 to infinity, it's just saying all the x values that are greater than 0. So what you're going to do, if you want to find the domain of this, you're going to take the inside, which is the argument. This guy is basically telling you where exactly I'm shifting it. Because if you notice in the previous problem, the only thing that affected the asymptote was the inside part. The reflection and decreasing it by 3 didn't affect it at all. So what I'm going to do is I'm going to place that guy in there. So that's going to be 3x minus 4. It's going to be greater than 0. And I'm going to solve for x. I'm going to add the 4 over. 3x is greater than 4. Divide by 3, x is greater than 4/3. So that tells me that my domain is going to be all numbers that are greater than 4/3. So starting at 4/3 and then going all the way to infinity. Okay? So using this little thing, we can immediately figure out the domain without having to graph it. Okay, so we kind of have a general gist of what it might look like. So find the domain of this guy. Find the domain. So what about if you had something that looked like this? F of x is equal to the log of negative 4x plus 2 minus 3. So first we know that the general domain of a log function is x is greater than 0. Okay? This is base 10, doesn't really matter. All the logs are basically the same. You're going to take this guy, put it in there. Negative 4x plus 2 is going to be greater than 0. So I'm going to subtract by 2 to both sides. So you're going to get negative 4x is greater than negative 2. And then I'm going to divide by negative 4. And when I divide by negative 4, x, notice that this sign is going to change because I'm dividing it by a negative. It's less than 1/2. So now notice that this guy, 1/2 is not included. And it's everything that's less than that. So that means that the domain is going to be from negative infinity to 1/2, not included. And that makes sense because you had a negative here, so there's going to be a reflection across the y-axis. So now the graph, the asymptote is going to switch places, okay? So this is just a quick and easy way to find the domain. The only thing that we really care about the logs is the inside. And this is actually a really good way because after we're done with the logs and exponentials, we're going to start talking about trigonometry. We're going to look at the trig functions. And to find the domain in the range of, or finding the equation of the asymptotes for trig functions is very similar to the way that we do it for logs.